Here I'm going to show you how to balance a redox reaction using the half reaction method. Here's one from your homework tonight. It's nitrite plus aluminum. The aluminum oxidizes into AlO2 1-, and the nitrite becomes the ammonium ion. The first thing you do is you don't really care what's being oxidized or reduced, just pick one of the species. So pick this one, NO2. Now you can see that we're dealing with the nitrogen, so what has nitrogen on this side? The NH4. So just rewrite this is your first half reaction. The way to do this is to balance the non-oxygen hydrogen species first. You can see that they are balanced. Step number 2, balance the oxygens using water. So you can see we have 2 oxygens here, so we're going to need 2 waters on this side. Now that we've done that, you can see that we have 4 hydrogens on this side and 4 hydrogens on this side, so that's a total of 8 hydrogens. So we add 8 hydrogens on this side. This is step number 2, balance the hydrogens using the hydrogen ion. Step number 3, balance the charge using electrons. On this side you can see that this entire side, the 8 plus and the 1- add up to 7 plus. This side adds up to 1 plus. So how many electrons do I have to add to this side to bring it down to 1 plus? I have to add 6 electrons. Now this is tricky, but look and test it right now. 6 and 1 is -7. 8 plus -7 is +1. Over here we have +1. Pay real close attention to your signs. Okay? This is balanced. This half reaction is now balanced. Step number 2 is to grab the other half reaction. So it has 2 parts. The reactant is aluminum and the product is AlO2 1-. Same steps. Balance the oxygens using water. So we add water to this side. Once we've done that, we balance the hydrogens using H+. I'm going to need 2 waters, so make sure I pay attention to that. So I have 4 hydrogen ions on this side. So notice how I balance the hydrogens. Now what? Balance the charge using electrons. On this side we have 0. On this side we have 4 plus and 1-, so that's a total add of 3 plus. So I have to add 3 electrons to this side to get it to balance. Now the charges are balanced on both sides and both half reactions. Now, before I can add these together, I have to make sure that I have the same number of electrons being lost as I have being gained. This is the reduction step. You can see that this nitrogen is gaining 6 electrons. This is the oxidation step. The aluminum is losing 3 electrons. In order to balance these 3 electrons with this 6 electrons, I have to multiply this reaction by 2. So when I multiply this entire reaction by 2, I'm going to bring this one down just so that it's compatible or easy to see. NO2- plus 8H plus yields NH4 plus 2H2O. I'm going to multiply these together, so 2 times 2 is 4, plus 2 aluminums makes 2 AlO2 1- plus 8H plus 6 electrons. Okay? Now we add the 2 together. Now that you've got the same number of electrons on both sides, you simply add them together. So all of the reactants and all of the products go on each side of one single arrow. All of the reactants. Here we go. 6 electrons, the nitrite, the 8 hydrogens, the 4 waters, and the 2 aluminums. Over here we have the ammonium, the 2 AlO2 1-, the 2 H2Os, the 8 hydrogens, and the 6 electrons. Does all that show up on the page? Not quite. Well, in any case, I have 6 electrons here, 6 electrons here. What I'm doing is treating this like an algebra problem. This arrow is essentially the equal sign. Since I had 6 here, I brought these 6 over. They cancel each other out. Here I have 8 hydrogens on this side and 8 hydrogens on this side. So I have a even-steven hydrogens. On this side we have a 4 waters and 2 waters, so I bring these 2 waters over, and this becomes 2H2O plus NO2 1- plus 2Al yields NH4 plus 2AlO2 1-. Now at this point, if it was an acidic solution, you would be done because you've basically finished the problem. So you could check yourself and see if everything is balanced with respect to charge and with respect to atoms. We have 4 hydrogen atoms and 4 hydrogen atoms. We have 1 nitrogen and 1 nitrogen. We have 2 oxygens here and 2 more. It's a total of 4 oxygens. Here we have a total of 4 oxygens. Here we have a total of 2 aluminums and 2 aluminums. The total charge on this side is 0. The total charge on this side is negative. Oh, sorry, the total charge on this side is 2 minus and 1 plus is negative 1. Negative 1 on this side. This thing is balanced. Now, the final step with a basic solution is to find all of your hydrogen ions and add the equivalent number of hydroxide ions to it. Now, in this case, I'm sorry to say this wasn't the best example because all of the hydrogens have canceled. Here, you can see the 8 hydrogen ions. But let's just say that there were 3 hydrogen ions. First of all, I'm going to box this, okay? So this is the answer to this question. But pretend there was a hydrogen ion, like 2 of them here. Well, what I would do is add hydroxide to both sides, okay? And what that would do is then this becomes water. And then this becomes OH, and that's how we balance it with a basic solution. You just have a lone OHs left over at the end of the reaction. Okay, I hope this helped. Oh, I didn't show you that example. So here is my H pluses. So since there were 2 H pluses, you would add an equivalent number of OHs, which then make water. And you had to add OHs to both sides equivalently, and so that's the reason that works. And so at the end, you make water here, you have an OH here. If this was the case and there were waters on this side, like see these waters, you could bring them over and cancel them appropriately, but you'd still have OH 1 minus. The reason this one works in a basic solution is because the ammonium ion is, remember what it is, it's a basic part, okay? So that's that reaction. I hope that helped.